So there's a couple of things I want to work on this time. One is parsing return types and return statements, and then I'm going to move on to writing a basic type checker. So to start with, we'll just go to the, let's say, the decals.fin test. So we'll rename this to be called no returns, maybe. We'll have another one called single return. And the thing that I'll expect from this is I'm going to allow multiple returns. So I'll have some string called returns that then gets followed by all of the string representations of the AST that represent those types. So in the beginning, it's just going to be identifiers because we're just going to do basic types like integers. But here, for example, we'll have like a S32, and that will come after, or come before the body here. We'll also want multiple returns. So in this case, we could have, for example, S32, S64. And in the case of multiple returns, I want it to be the same as Go, where we basically just have to surround it in parentheses. And the reason for the parentheses is because the other thing I like about Go is that you can define a bunch of parameters and then tell it what the type is at the end. So if I do this, and then I say, for example, foo is a function, how do I know whether this is a single return or multiple returns? You know, I don't want to do any backtracking or anything. It just complicates everything. So if I require some parentheses for the multiple returns, I know that it finishes here, and then C is actually another parameter rather than part of the return type for the function pointer. We won't deal with parameters and arguments right now, though. We'll just do returns. We'll have another test in here called statements, maybe. I'll change this around a bit later at some point, but we'll say, for example, let's do single return here. So we'll do S32, we'll return 1, 2, 3. And for this one, we expect we're gonna, because this is a list again, we're just gonna call it the same thing. It will be returns, and then it will have 1, 2, 3. So this is the one for this, and the other one I'll do is we'll do a couple of them. So we'll say we got no returns. This is just going to be an empty returns statement. Single return, and then multiple returns. So let's say 4, 5, 6. Just to keep it simple. So if I run this test, it's going to break. So because we're not parsing out return types, we expect the start of a body, but we found S32. It's also a little annoying that the empty string comes out for EOF. And I don't need to display multiple errors per line. It's probably more useful if I just stick to one error per line. So we'll keep a cache of lines that we've generated errors for in the parser. We'll do that first before we fix all of the errors. So we'll say scene error lines. This can just be a map of int to struct. So that means I'll need to clear the state here. Actually, I'll do it down here. We'll wrap it in a call to clear. Clear scene error lines. And then in the error function, we'll query the line and column first. And then we'll say that if we've seen the line, we'll just return. Otherwise, we'll add it to the map. And since this is being lazily initialized, I only need to do an if statement here. So we'll say if this is equal to nil, then we'll set it equal to make map int to struct. So that should give us only one error per line. And then I want to set this to the string EOF, but I can't just assume, I don't want to just assume that every empty string is EOF, and I don't want to put it in this lexeme function here. So what I might do instead is that these are all the same. So if I remove all of them and have just a function called p.found where I pass in the token that I care about. So we could have this helper down here called found, where we return the lexeme for the token. So this is token start and end, but if the token's kind is equal to EOF, we'll return just the static string EOF. So here expected semicolon found EOF. So now I can just start parsing out the function a bit more. So if we want to parse function decl, after the right paren, so this is where our parameters will be, but I'm not doing parameters right now. So we'll need a returns slice, which can be AST node. And if the p.next.kind is an ident, let's say, or what we'll do actually is say if the p.next.kind is not a left brace, then we'll expect the return type list. So here we'll say a switch on p.next.kind. And in the case that we see a token, if p.next.kind is a right paren, or a left paren, then we'll want to enter into a loop where we loop multiple returns. Otherwise, we only want to parse a single return type. So we'll do the single one first. So this will be append onto returns. We'll have a new function called parse type hint. Then in the case of lparen, we want to advance past the left parenthesis. And at the end, we want to be able to consume a right paren. Operand. So for this whole time, we're going to say for p.next.kind is not equal to right paren, and we need to put the EOF check in here so we don't infinitely loop. Then we'll basically try and parse a type hint, and then if the p.next.kind by the time we get out here is not equal to token.rparen, then we'll expect to consume a comma. So that should build up our return slice, and we'll put that as a new field in function decl. So this is returns, it's going to be a slice of nodes. I'll need to print this out as well, so I think we'll just do a slice of strings here. So instead of assigning these to variables, we'll just append to the strings. And then when we come down here, we'll just do strings.join strings by space. And then after ident, I'll need to build up the returns. So we'll say if the length of node.returns is greater than 0, then we'll build up some returns strings here. And we'll just loop over each return, ranged node returns, and we'll just build up this slice here. So we'll say append returns sprint. We'll pass in the return along with the file. I've got a syntax error somewhere. Oh no, I don't. So I'll build up all of the return printing, and then we'll say that strings equals append to strings, where we'll just do returns strings.join returns by space as well. Okay, so we need parse type hint. So parsing a type hint, right now I'm only parsing basic types, which means they're just going to be identifiers, but later on it might be things like structs, definitions, unions, function signatures, all kinds of things. So parse type hint is just going to start by returning an AST node, and we're just going to call parse ident for now. Later we can expand this when we have more types. So I need a space after the word returns here, and that all actually works, but I do want to, let's go to decals and just break one of them. I think I want to put these error messages on the same line as want and got, because it will be easier to compare them. So we'll go to the parser test here and just remove these new lines and tabs. Okay, that's a bit easier for me to read. So, okay, let's go back and fix that test. So that all works. So we do need, we do want to be able to parse return statement. I don't know why this one is not, oh, yeah, I actually need to run the test. So let's add statements into here. Okay, now we get some errors. So we expected identifier, literal, or unary prefix, but we found return. So we'll need to expand that error message a little bit to say in the parser, unary prefix, expected identifier, literal, let's say unary prefix or return. This error message might get a bit long, so I'll have to figure out a way of changing it if it does get too long. Found return, so I need to basically start in parse statement here. I actually need to decide what to do based on the next token now. So if we switch on next kind, and in the case that we see token dot return, we will parse a return statement. And then in the default case, we'll try to parse an expression statement. So we need a parse return statement here. This is going to take pointer to AST return statement. And return statement is just going to be it's just going to be a struct that has expressions. So these will just be AST nodes, which is the type thing. So I need expers here. So expers is going to be ast.node, and in AST over here, I need to actually create a new type. So we'll have a return statement. And in this case, we're just going to have expers. And so the span of this is just going to be that we need a start. Actually, I think we just need a start and an end. This will be the start and the end of the actual lexeme. And then we'll have expressions. So we're going to switch on the length of the expressions. So in the case that there's 0, we basically just want to return the start and end. In any other case, let's say in the case of, oh no, this is okay. We'll just say if this is 0, then we'll do this. Otherwise, we're going to return r.start, and then end will be r.expers, where we take the len of r.expers minus 1.span. So we need a start and end. Start can be start, end is end. So in here we'll just save those things. We'll say p.next.start, and end is actually the end of the token this time. So for as long as we don't see a semicolon, we want to try parsing out expressions separated by commas. So it's going to be pretty similar to the loop that we have here for types. So for the whole time that we don't see a semicolon, we want to try and parse an expression with power none. And if we're not at a semicolon yet, we expect there to be a comma. And then outside of here, we expect there to be a semicolon. That should be a return statement. Found return still. Parse statements. Do we actually get into here? Yeah, so it says return there. Statements line 4. It says that it expected a comma, found ending brace. 3 is saying that it expects one of these things, but it found return. Okay, I think that's just because, oh, right. When I come into parse return, I need to actually consume the return. So we'll put that after we've saved the start and end. Okay, let's just get rid of these prints. So now I need to actually handle printing the return statement. This is going to be basically the same as this one. So let's just call this strings instead, just to keep it the same. So for all of the expressions here, we want to build up these strings. Then we're going to do this sort of thing. So this is going to be returns. Okay, so now I need to update the walk function to walk the return statement. And that passes. So we've got return types and return statements. So now the way that now that what I want to do is start on a basic type checker. And so the way that this will happen is that we'll traverse the AST just like we do with like printing it. And when we reach the leaf nodes, we'll try and get types. So for example, if we get to an integer literal, we'll get the type of that integer literal. If it's a literal, then it will start out as an untyped int, and we'll take those up the tree. We'll try and compare them as we go. I want to compare by pointers though, so I need to intern type instantiations into like a global cache so I can compare on pointers. And I'll need to be able to print the types to test them as well. So I'll need to be able to map AST nodes to types and then allow the printer to actually print them out. So we'll start with the types package. We'll have types.go, package types. A type can be something that has the ability to return an ID, because we'll need the ID for things like interning functions or function signatures and things. So we'll have types be an ID. Then I'm going to need, I think I'll start on the cache. So we'll have type cache struct. This will take a mutex, be a read-write mutex. And we'll just store basic types for now. So we'll basically have a map of basic kind to pointers to basic structs. So basic kind would be something like untyped int, S8, S16, 32, 64. And those will map to an instantiation of that type, which will be a pointer to a struct that contains an ID and the kind. So here we'll want to, this should be a global cache, so I'll create it new here. We'll say pointer to cache. We need to make the basic map, basic kind to basic pointer. And then we need some function here called basic, which is what we'll use to look up a basic type by the kind. So we'll say basic kind returns basic. So here we need to take out a read lock. And check to see if we've got the type. So we'll say type OK, c dot basic, look up in the map. If we got it, then we'll return it. Otherwise, we need to do a write. So we'll say lock and defer unlock. But in this case, we want to check the map again, just in case between these operations someone else cached a type. So we'll check to see if we got it. If we did, we'll return it. Otherwise, we'll create it. So this will be basic. We'll need an ID, so we'll say that this is some atomic int. And we'll also store the kind. Then we'll store that in the basic map by the kind. And then we'll return the type. And yeah, we need the atomic. So var type ID will be atomic.uint64. That should cover looking up and creating basic types. So we'll just have a basic.go, package types. We'll have type basic kind here. This can just be an int. We'll also need a basic struct. So this has the ID, which is uint64, and it's got the kind, which is a basic kind. Then we need some basic kinds, so we'll say that invalid is the 0 value. We'll have untyped int, and then we'll just have like a S8 to S16, 32, and 64. So I'm going to need to be able to create a string from the basic type, which is just going to be the name of the kind, basically. So I think I'll just implement the stringer on here. So we'll say basic string, return basic names b.kind. So we'll have our basic names table. And we'll use these enum values as indices for the names. So we'll lowercase those, and untyped can just be int. We also need to implement the interface for returning an ID so that it's considered to actually be a type. So this will be uint64, return b.id. So that takes care of the cache and the basic types. I think we just need a checker now. So checker package types, type checker. I'm not going to put anything in this right now, but I'll do func new checker, just so we've got a way to create it. Return checker, and we'll have a function on it, tc, or yeah, we'll call it tc for type checker. This will be check. It will take in an AST node to check along with the file, token.file, for any error messages, and it could return an error. Okay, so this thinks I want the Go packages right now. I'll sort that out in a bit. Okay, so I think the type checker tests are going to be basically the same as the parser tests, but I want to use tc here as a variable for type checker, so I'll change this to file name. And we'll just copy this out and create checker tests. So we'll paste this in, change the package name. So the main difference here is we're going to have tc is the types.new checker. And in these tests, the the parse should always complete without error. But the tc.check call with the node with the AST from the parser could error, and we might want to test for that. The rest of it's exactly the same because we're just walking the tree and looking for tests to execute. So let's do test data. We'll just call this something simple. We'll just do checker.fin for now. And in here we'll say that, for example, we'll do expers again. And let's say that we've got just the number 1. We'll want to have 1, but then we need to print the type as well. So in the case that we're printing the type, I think that the easiest way to do that would be to append it with a colon. So it will start out as an untyped int, but then when we leave the expression statement, we'll give it a more concrete type, so we'll assign it S32 by default. And then we'll want to do the same, for example, for binary nodes. So this will be, plus, and then we'll have 2, which will also be S32, and the result of the plus will also be S32. So this type will propagate down the tree to these other untyped integers. So I need to, we'll run checker.fin. That seems to pass at the moment, I think. Test checker. Found package types and checker. Yeah, okay. So this should be types. Okay, not enough arguments to new checker. Oh, I guess the Go standard library also has a types.new checker. Okay. Right, well, let's get rid of that import and we'll make sure that it knows that we want to use my ones instead. And we'll do the same over here. So we've got AST and token. Okay, so now we get some failing tests. We basically want to annotate these with the actual types. So we need to start assigning some types and then figuring out how to print them. So check here, we'll just call a lowercase check where we just pass in the node that we're currently checking, and we'll keep the state of token.file in here. So this check call will reset the internal state. Then it will call tc.check on the node, and then this is where we would check to see if there's any errors and generate an error just like the parser does. But we're not going to actually do errors right now, we're just interested in annotating nodes for the tests. So we'll pass in node to check to this check one. This should maybe return a type. So every time we check a node, it will return a type that we can use. So here we'll basically just switch on the node with a type switch. And in the case, so let's go to print for a second. So we've got all of these cases here. Let's just take all these cases and we'll put them in here. So this is AST dot something. And now we just need to, we'll have to panic as well. So in the case of bad, for example, we'll just return cache.basic, and we'll look for the invalid type here. In the case of int, we'll want to give it the untyped int. But I also want to sort of tag the AST node with the type so that the printer can look it up. And then later on when we're generating IR and stuff, the IR code gen can also look up based on the node as the key. So for example, we'll want some global, we can use the cache to store the node map. And we could, for example, say something like set node type. So we'll pass in the node and then we'll pass in the type, which would be this one. But I'm probably going to have to do this quite a bit, and these 3 lines are a bit awkward to write all the time, so I'd like maybe I'm passing in the type here. This could just return the type that's being assigned, which means I could just pass this in here. So this will tag a node with a type, create the type in the cache if needed, and it will return it all at the same time. So we'll have a set node type, and then we'll have another one called node type, which will just look it up. So we'll go and put that in the cache here. So maybe we'll say nodes is make a map of ast.node to type. So nodes is ast.node to type. And then we'll just have some global functions down here. So we've got set node type. This will take in a node, ast.node, and it will take in a type. And it will return the type as well. So for this, we'll say cache.mutex.lock. And we'll just defer unlock. So this will do cache.nodes, and we'll just pass in the node and set that to be the type. Then we need a node type. So this is just going to take in a node, and this will just return c.nodes and just look up the node. So here we'll need a c.mutex.readlock, and we'll defer a call to read unlock. So that takes care of integer. I think maybe let's go back to the printer. Yes, so module here is just going to do the same thing. It's just going to loop over all of the decals and tc.check the declaration. Function declaration will just do the body for now. So we'll say tc dot body, or sorry, tc dot check node dot body. Block statement, same thing, but just with statements instead. The return statements can. Well, let's just we'll wait for the return statement. We'll wait for these for ident and these other ones as well. And binary will be done in a minute. So we'll just test the, or actually we'll say return cache dot basic. We'll just return invalid for now from here. So undefined C on line 51 in cache. That's because I'm using C here. I should be using cache, the global variable. Missing return checker 51. Yes, so each of these should return something. So in the cases where we're not supposed to actually have a value being generated, we'll just return invalid. Okay, so now I need to try and annotate these with types. And I'll basically need to do that in the printer. So we'll have another function here called sprint type. This will take in some AST node. So this will be node. We're going to bring back a string. Then we're going to look for the type in types.node type. Pass that in. If type is nil, so if we didn't find it, we'll just return nothing. Otherwise, we'll have a switch on the type. We'll have a default panic, because we should be handling all of these. And in the case that we see types.basic, we'll return the type.string. So this will give us the name that we did in the stringer interface earlier. So I think this is actually going to give an import cycle. Yeah. So I'll need to move this print out. So we'll call this AST fumpt maybe, and move it into there. Call that. So this now needs to be AST.node. All of these cases need to be prefixed with AST, and this one needs to be AST.node as well. Okay. Alright, is there anything else? Same thing over here. Okay, so now we get this test. It runs, but we're still not actually annotating anything. And we're not printing any of it either. So we'll go back to print first of all. So in the case of something like int, we'll say string equals this thing, and then we'll say if type equals sprint type, passing in the node, and type is not the empty string, then we'll do plus equals colon plus type, and we'll return the string. So we'll probably also need to do this on binary as well. So we'll say op is node.op.string, and then we'll do the same thing, but with op, and then we'll replace this call with op. So that still compiles. So this time, we are actually annotating integers, but we're not propagating a concrete type yet, so they're just coming out as int. And then for binary, I'm not actually doing anything in there, so we'll go to the checker and do binary first. Checker does binary. We'll basically do a tc.check on node.lhs and RHS. So that now annotates the LHS and RHS. And then we'll need to basically do a set node type and return for this as well. So let's just say that it is, we'll keep invalid here, and what we'll do is we'll say LHS equals this type, RHS equals this type, and if LHS equals RHS, then we'll return the RHS. So now they're all being annotated, but they're all untyped. So we just need to decide how to actually make these things more concrete. So what we might do is that after a statement, we'll say that we'll get the type back. And for now, what I'll do is I'll just say if the type is, if the type dot is, let's say, how can I check this? If type dot, let's just say if type is equal to cache.basic untyped int, then what we want to do is propagate a type through the tree instead. So in this case, what we'll do is we'll say that tc.propagate we'll say propagate onto this node, so this will be statement. We want to propagate the cache.basic S32. Let's do S64 so we can see the test failing. So here we'll just create another function, propagate. We'll propagate this type into the tree. So whatever node is here, we're just going to say set node, and we'll pass in the type. So this should take care of the integer case. Set node type. So this takes care of propagating a default concrete type into the integer case here. So this is S64 now, but these ones in the binary operator aren't getting the. It's not propagating down. So this the plus is S64, but the others are still untyped ints. So here we'll do a switch on the node, and we'll say that if we have got an AST binary. Then we'll want to propagate into LHS and RHS. So these are now also S64. So if I change this to S32, that makes S32 the default case for any untyped integer, and now everything passes. So maybe I'll leave it there for now, and we'll get on to type checking return statements against return types of functions in the next one.